So today, AP Chemistry, we're looking at how we start to actually measure our pH when we start to look at these different acidic solutions and kind of these buffers. And you're familiar with these. We're just going to hit this kind of quick just to kind of reintroduce this idea and then talk a little bit more in detail about these indicators because they are important. We do use them often in the lab when our experimental design does not necessarily require particularly precise results. Anyway, let's talk about it. So there's a couple different ways that we can start to measure the pH of our solution or our substance at any given point in time. The most common is a pH meter, and these are really nice because they have that digital display. They are technically conductivity testers, and so there's a little bit of calibration that goes into that. There's a couple of limitations to when you can use that. But far and away, these are the best way for us to get a very precise and accurate measurement of our pH at any given point in time. And if you got them, that's great. But if you don't have access to, say, a computer or a probe, there are other options or alternatives that we can use in the form of acid-base indicators. And we've been using these since Chem 1. We think about phenolphthalein, a big one. We see that one a lot. Bromothiol blue, or a universal indicator, or even the pH paper, the litmus paper that you can use to test. And typically, when we're using these indicators, we can actually see these change color if our ratio is 10 times more than the other. So usually you have to be either 10 times more acidic or 10 times more basic for that to actually register a color change, which starts to introduce a little bit of experimental error because we're now kind of getting outside this range. And additionally, when you're looking at these indicators, they typically change colors over a period of a pH of 2 pH units, which means you're going to kind of start to see a color change, and then it's going to gradually change from one color to the next until you finally get to kind of that final pH color. And so again, they can serve a usable purpose, but we have to keep in mind that there are some limitations to how we can use these. The reason for this, kind of this range that we see, is because our acid-base indicators are actually weak acids. So we sometimes will abbreviate them as HIN. This is just a weak indicator or a weak organic molecule, and then it kind of breaks into, when it reacts with a base, breaks into its conjugate base, which would just be the indicator anion or the I minus. And they're tricky because people perceive colors different. I'm reminded of, is it the black and blue dress or the gold and white dress, right? And how we perceive colors is uniquely different. And so again, we're looking at could potentially introduce some error depending on how consistent we are with the reading of our indicators. And so again, lots of tools we can start to use. These indicators are unique though, and again, because of the range. So here we know this is bromothiol blue, excuse me, bromothiol, potato. In the presence of an acid, it is very much this bright yellow color. In the presence of a base, it turns to this blue color. But then what is this thing in the middle? Is it neutral? Is it slightly acidic? Is it slightly basic? It's like a greenish, yellowish, and so that's where we start to kind of see this range of colors. So here's a bunch of different indicators. These are all technically weak acids. And so that's why they change colors. When you react it with a base or an acid, if you're coming from a basic solution, when it reacts with a base though, you cleave off one of those hydrogens, and all of a sudden our molecule absorbs our light in a different frequency or wavelength. And so we actually perceive a different color of light for our solution. And there are oodles of these. And so this is where we can sometimes be selective depending on what it is we're testing or where our pH range is going to be for our buffers. We could theoretically pick an indicator that would suit the needs of our titration or our reaction. And so if you know you're working in acidic solutions, anything here at the start technically would work for that. So thymol blue goes from red to yellow, right around the pH of 2. But again, notice there's this range that we kind of slowly see the color change from start to finish over that pH range of about 2 pH units. Phenolphthalein is pretty good because we see that color change happening right after we get that pH of 7, right? Kind of from pink or white or colorless to pink. And so again, depending on where you're at, depending on what you're testing, if you're trying to make a specific biological experiment with a specific pH with a buffer, you could dial it in with one of these indicators. Now you'll notice there's a couple of these, like thymol blue and our alizarin, pretty rare indicator for that one. We actually have two different color ranges. We actually have multiple areas where we see two different color ranges, and this must indicate there's two H's we can pull off. These are diprotic. And so because we have multiple H's, we can remove from the indicator, we actually can have more than one kind of range or bandwidth on our pH indicators. It's just nice to talk about these and think about how these actually work and why we would use them and under what circumstance. And depending on what you're doing, they do work. They are fairly accurate, but it is a source of potential error. We use phenolphthalein all the time, for example, and that's because it is pretty close to 7, and usually the pH changes really quickly. And so even if it's just starting to change, it's only been the difference of a half a mil because you've only added 1 drop to go from a pH of 7 to a pH of 10. And so it actually still works because of how quickly these pH changes occur. So pros and cons, kind of depends what you're doing, but this is how our indicators work and how we start to see their different colors exhibited in our different solutions.